Next, we're going to take a look at an example of an ellipse that's not centered at an origin. Once again, they've just given us just some points, and we are responsible for figuring it out, doing everything we can with this thing. So what we're going to do is we're going to start with a quick graph. And our quick graph is going to look like, okay, so I see 2, -3, I see positive x values and negative y values. So I'm just going to kind of draw not too much of a positive x version, but mostly below there. I'm going to give myself, I don't know, 6 or 5 hash marks in the positive x direction. 1, 2, 3, 4, 5. Couple in the negative, who knows? And then just go down a few, 1, 2, 3, 4, 5 in the negative y direction too. That should give me enough. 2, -3. We'll start with the center. We'll just put C squiggle there so I keep track of it. The focus is at 3, -3. So over here at 3, -3. All right. So we're hanging out. Focus is real nearby there. And a vertex at 5, -3. 5, -3. Okay. So what do we have? We have if the vertex and the foci are in the horizontal direction, we have a horizontal ellipse here. Okay, so what can we just identify right away? Well, the distance from the center to the focus is C. That value is just 1. And then the distance from the center to the vertex is your A value. And so that value is 1, 2, 3. And so we could also go ahead and plot our other symmetric focuses, or foci, 1 to the left and then 3 to the left, 1, 2, 3 to the left, right over there. Something like that. So now we need to find our B value, the distance in the vertical direction to our... Am I doing the same problem again? No, who knows? Okay, the distance in the B direction for our thing. So what do we know? Okay, so far, longer in the X direction. So we're going to have a focus going to a center. And that distance is 1. C equals 1. Now the vertical here is going to be our B. It's going to be to our minor vertex. And that's going to be B. We don't know what B is. That's what we're trying to find. And this distance here is always the distance from the center to the major vertex, which doesn't reflect the triangle, doesn't match the picture for the hypotenuse always. So this is A equals to 3. Solving for B, we get B equals the square root of the hypotenuse, 3 squared, minus the adjacent one, 1 squared, the other leg. 4 minus 1 gives me the square root of, oh, no. 3 squared is 9. 9 minus 1 is square root of 8, which is equal to 2 root 2, which we've seen before is about, I don't know. I want to say on the last page, it was like 2.24, and over here I have something totally, no, that was for root 5. That's something different. This is 2.8-ish. Yeah, 2.8. Okay, that's pretty good for a quick graph, but it's a little cluttered up if I want to do a better job here. So we're going to draw, I think that picture is going to look pretty good, but I'm just going to give myself a little bit bigger of a section here to draw it in. Okay, so very, very similar. 1, 2, 3, 4, 5 in the x direction, couple in the negative x direction, and then 1, 2, 3, 4, 5, and we'll see if that's enough. Again, center 2, -3. Focus 3, -3. Other focus on the other side of 1, -3. Major vertex 5, -3. V, F, F, C squiggle, and then other vertex. Let's see, the distance there was 1, 2, 3, so we got to go 3. There we're at 1. 1, 2, 3, -1, -3. Now for our B value, let's go ahead and just put in our major axis. Let's put in our minor axis, just straight up through that center. That's going to help us kind of when we go to plot our minor vertices. We start at that value and we travel up a distance of B, 2.8, so almost 3, but not quite 1, 2, almost 3, 2.8, 2 root 2. And similarly, for your lower minor vertex, just go down 2.8, 1, 2, 2.8 there. Now you've got all the points you need to draw your ellipse, which, given the imperfect scale, looks somewhat circle-ish, but that'll be okay. Now we just list everything we know. list what we know. Identify your vertices. I'm going to borrow the writing up above instead of having to rewrite everything. So we've got 5, -3, so the other vertex is -1, -3. The focus, first one we were given is 3 √3, 3 -3. This one is 1 -3. Center is 2 -2. We've got all those things written down. So we need to now do the minor vertices. Well, they are on, what's their x coordinate? They are both on 2. That doesn't change. And what do we do? Well, we start at the y value of -3, -3. And what do? We go up 2 √2. Or we go start at -3 and we go down 2 √2 by subtracting 2 √2 and adding 2 √2 in the reverse respective order. Last but not least, we could identify our axes. Our major is longer in the horizontal direction, so horizontal line is y is equal to -3, and a minor axis is equal to x is equal to 2. All right. Other summaries, we've got A is equal to 3 above in our triangle, C is equal to 1, and B, let's add it to our triangle, 2 √2. A, B, and C are 1. Well, we can now put this all together into the equation. X minus the x coordinate of the center is going to be x minus 2 squared over A. A is 3, so 3 squared, plus y minus the y coordinate of the center, -3, quantity squared, all over b squared. Well, b was 2 √2, and you've seen it before, but 2 √2 squared is going to give us 8. It's going to give us 4 times square root of 2 squared is 2. 4 times 2 is 8, equals to 1. Simplify that jazz, and you'll have your equation. X minus 2 squared over 9 plus y plus 3 squared over 8 equals to 1. And if you're thinking, hey, this looks like one of the earlier examples we did, it is. We just did it in reverse this time.